Hey folks, in this lesson, we are going to take a quick look as to how to use Slither and how it can identify vulnerabilities. So you can see on your lesson that there is a contract code, which is a simple storage contract, right? So you can find that on Remix as well as a default contract. When you go to Remix, you'll find one underscore storage dot sol. We have basically taken this piece of code. And we are going to be just showing how Slither can identify vulnerabilities in contracts, right? So what I recommend is to take this piece of code, paste it at a location of your choice. So the project folder that I have right now, to minimize this and make this slightly bigger. So the project folder that I'm using right now is Solidity Advanced Module 3. Under this, I have created a file called storage.sol. So if you want to take a quick look at what this is basically the same contract as the storage contract right in front of you. So now I have installed Slither. If you have seen the previous video, then you must have been able to install Slither as well. If you do not have a MacBook, which is Mac OS, which is my OS, I recommend using WSL if you have Windows or Linux operating systems, right? So these kind of debugging tools work best, in my opinion, on Linux based operating systems. So now that you have this piece of code, storage.sol, if you have not changed your Solc compiler, that is, Solc is your Solidity compiler. If you have not changed the version of that, using pip3 install Solc select, you can change this particular version. I already have 0.8.9, but let me still just type this command. And you can see that once you have installed it, once you've installed the Solc select, and then you have installed that particular version of Solidity that you want to switch to, you can use the command Solc select use and then switch to that version, which is what I did. Say switch global version to 0.8.9. Now, once you have copy pasted the storage.sol code, you can just use this command slither storage.sol to run Slither on your storage.sol file. Now you can see that there is a specific out, and you will also be seeing that output. I've pasted a screenshot as well. You will be seeing the same output on your screen, and you should see that this output is green in color. So the Slither finds vulnerabilities at different levels, right? It can be very critical, which is generally indicated by red. And then there is like mediocre level vulnerabilities, which is indicated by yellow. And then there is like, okay, this vulnerability is not going to damage your code, to an extent that it's going to drain funds or something. So those are green. That is, you don't have to worry about them too much. Now here, because this contract more or less, it's a contract that Remix gives by default. So of course, they're not going to give you something with a lot of vulnerabilities, but that's just good for you to understand what kind of vulnerabilities does this throw and what does it mean, right? Now, Slither itself has been written for specific compiler versions. That is, it has been tested with 0.6.12 and 0.7.6. I believe this is the recent from my understanding, but I'm going to double check this for you on Slither as well. So if you go to Slither GitHub, you can see the examples, you can see scripts, you can see tests, and then you can see that there are tests for like various versions. For example, if I say check upgradability, it's going to show me like, what are the different Solidity files that are here. So you can also run these tests yourself. And then there are also sort of tests that are there for various versions. Like, let me try to find something. Okay, let's say arbitrary send eat. So you can see that this arbitrary send eat test has been tested for various versions of Solidity 0.4.25, 5.16, 6.11, and 7.6. So that's why over here you may see that because our version is one of the latest ones, that is 0.8.9, it is asking us to, consider deploying it with earlier versions which are stable and have been tested. So it says that 8.0.8.9 is not recommended for deployment. And then it also gives you a reference as to where this error is coming from. So if you click on this reference, you should be able to see the wiki in which this particular error is being talked about. So you can see that deploy with what are the recommended versions for deployment. So it asks you to deploy with some of these versions which are more stable, don't have too many bugs, and have almost all the fixes for earlier bugs. So for 8 dot, the recommended version is 0.8.16, right? So this is a compiler version that it recommends you. It's not necessary that you have to follow it. You may want certain features that are there in earlier versions as well. But this is the recommended version. So unless and until you are very specific about deploying a certain version, we generally recommend you to go with this, right? So this is a best practice that this has highlighted for you. And it has also highlighted that on storage.sol, line number 17 to 19, right? What I'm going to do is I'm going to open this up in VS Code so we can actually see the line numbers. It's telling that this particular UN 256 should be declared external, right? It's probably not being used, it's not having any other visibility to it, like associated with it. So it recommends you to declare it as external. Some of these recommendations, not all of these are related, might be related to security. Some of these recommendations are also related to optimizing your, memory usage, your storage, and things like that. So these are essentially just best practices, right? And then also retrieve function. It tells you that it should be declared external. And then it gives you a reference as well. That is public functions that could be declared external. Under what circumstances should you declare public functions as external? Why is it helpful, right? You can see that it is mostly here for optimization, right? So you can make these changes in your file, says storage.sol, and then it says that this one, and then it asks me to make this external. Let's try to run this again. Okay, I see that my assumption was right. Looks like external cannot be. Okay, this was the store function. My bad. I did not see that. And I tried to add a visibility to a variable that does not exist. External is not a visibility for a variable, which I already knew, but for some reason I read this wrong. So you can see that because I changed the store function and the retrieve function and made it external, right? As per the suggestion is gone. And we still get the suggestion for the 0.8.9 because that's the version we are continuing with. So this is just like a very brief glimpse of what Slither can do and just a very introductory setup for you to understand what Slither is doing. We will look at another example in the next video, which identifies a couple of more critical pointers and how we can fix those pointers in our Solidity smart contract.